Okay, another very interesting transformation for any function is, and a question that persistently comes into our mind when we are looking into any general function y equals to fx. What happens if I, instead of putting the value x, I put the value minus x? Okay, just for example, what I mean to say is that in case fx equals to x square, okay, fx equals to x square, what happens to the value fx equals to x square? Then in case I put the value 1, I get 1, okay, but in case I put the value minus 1, I still get a 1, right? So this is a kind of a transformation. This is a kind of a transformation, not for this question, but for some other functions apart from this. This is an even function, okay? Here we are getting the same value. But in general, for any general function, what will be f of minus x? F of minus x will essentially just be the mirror image. Will essentially just be the mirror image. Even for this, we are getting the same values, right? So what is happening is that if I look at the positive value of x's, I'll get half of the parabola like this, x square. And if I put negative x's, I will still get positive y's, and it will be a mirror image of what I have on this side. Okay, so similarly we can take an example of ex. Okay, now ex as a graph goes like this. I don't need to, I have already shown you this graph of ex, how to be made. You can refer to that video. Now y equals to ex moves like this, okay, cutting the y-axis at 1, okay, because e0 is 1, so okay, so e0 is 1, so hence it goes like this. Okay, what will happen when we have e to the power minus x? What happens when we have e to the power minus x is essentially that you will just have a replica which will be a mirror image of the kind of a graph that I have made out here. It will be a graph out here, okay, cutting again at y equals to 1, okay, cutting again the y-axis at 1. It will be just a mirror image, just a mirror image. I can give you probably another example in it within this periphery. We can take an example of, say, what happens when x is say y equals to minus 1 by x square. Okay, if it is minus 1 by x square, then again I've already given you this example. If I put fx is minus, then what will happen to f of minus x? It will again be the same, because x square will make it same. X square will make it same. So you can draw and try to look at it from the perspective of how will it look like. But now the next question that arises is, what we have seen right now is that if I'm taking minus x instead of x, okay, if I'm taking minus x instead of x, what happens? Now the next question arises that what will the function y look like in case instead of fx I change it into minus of fx. Okay, I change it into minus of fx. What will this function look like? So that's the fourth transformation. That's the fourth transformation that we will be looking at. The fourth type of transformation that we will be looking at is this. Remember that this is different from f of minus x, okay? In case of an odd function, right? In case of an odd function, if somebody had this question in the mind, in case of an odd function, what happens? f of minus x equals to minus fx, but not in general for every function, okay, only in case of odd functions, because a function is called odd only when this thing is satisfied, okay, only if f minus x equals to minus fx, okay. Now the same question that I took above, y equals to minus 1 by x square. Now when y equals to minus 1 by x square, what are the values that I can give to x? The moment I give the value 0 to x, okay, now x is in the denominator, that means y becomes not defined. Y is not defined, okay, y is not defined, okay. Now, so first we will draw fx. Fx is, first we will draw fx, which we take as y equals to minus 1 by x square, minus 1 by x square. So for that we are taking x value when it is 1, my y value becomes minus 1. When it is 2, my y value becomes minus 1 upon minus 1 upon 2 square. So it is minus 1 by 4. When it's minus 1, then the denominator still says, because it's x square, so it becomes positive, minus becomes positive, so minus 1 upon 1 is minus 1, and so on, okay. So what will happen to minus fx? Minus fx will become actually 1 upon x square. Instead of minus 1 upon x square, I have 1 upon x square. So what will happen? I will have all positive values. I will have all positive values of y. Y all positive. And here I had y's all negative. Okay? Because my numerator was negative, so therefore y's were coming out to be negative, and I had an x square in the denominator. X square becomes positive, so I had basically all numbers that were coming were negative, but now I have all positives. So essentially minus 1 by x square, minus 1 by x square, which has all negative y's, will be below the x axis because I have all negatives here, okay, minus y. So this will be below the x axis, and the curve will be like, it's a hyperbola. So it will look like this. So for every value of x, you have a negative value of y. For every x, there is a negative y, okay, there is a negative y. So x can be positive, x can be negative. And what happens to the function where I have minus fx? It becomes 1 upon x square. So we have all positive, so we have positive y axis, and even if my x is negative, my y will be positive, so it will be an image of this sort. So essentially again we have sort of a mirror image of fx, we have sort of a mirror image of fx, which will be minus fx. What you need to remember is that there is a difference between minus fx and f of minus x. The difference only disappears in the case of an odd function, because an odd function satisfies the property that f of minus x equals to minus fx. Okay, so that's what you need to remember.